Good afternoon, everyone. This is a recap of the week 5 lecture session. Due to some challenges regarding the last week lecture video, we decided to prepare a recap video. And then we're very sorry for the inconvenience it might cause. If you have any questions, please feel free to send me an email. If you require any additional information or support regarding this week lecture, please feel free to send me an email as well. I'm very happy to discuss with you and also to respond to your emails as soon as possible. Yeah. So actually, I prepared another video this morning, but I found out that I didn't actually save or record the video, so I'm having to do it again. So not a problem. So for the week 5 lecture, we're looking at verification and validation. We're going to talk about notes on verification and validation, discuss about the further code inspection method, and also automatic static analysis tools. The overview of this session include verification and validation process, the figure inspection method, automatic static analysis tools, and then review some notes on verification and validation, and also discuss about the automatic static analysis tools based on some anomalies. So the resources required for this content is the verification and validation notes, which can be found in the Appendix I document. Similar to what we talked about last week, is we will always discuss the appendix document and then we come back to the lecture slides to give you more information about the reading and also how this could be used to support your project and as well as your exam reading. So verification, validation. If you're testing to see that your product meets your requirement specification, this is verification. And if you're just trying to test to see how well you have addressed those needs that are supported by this requirement, this is validation, which represent, are you actually building the right product? In the VMV, we have 3 different features, which include the planning, software inspection, and automated static analysis. For the VMV process, is you're trying to look at the verification and validation in detail. VMV can be applied across every stage of your software process, mainly to discover defects and also to assess whether or not your system is usable in an operational environment. It will give you more confidence to ensure that your software is fit for purpose, is fit for use. And also, it doesn't really mean that your software is completely free of defect, but at least it's good enough for its intended use. And also that supports your confidence as well, which in this case leads to the VMV confidence, which is supported by software function, user expectation, and also the marketing environment. Also, we have the static and dynamic verification. If you're trying to discover problems during analysis, this is what we call about the static verification. And if you're trying to understand or to observe the behavior of your product or your software, in this case, you're looking at what dynamic verification. So please perform static verification if you want to discover problems. And then if you want to observe the behavior, perform your dynamic verification. Remember, you're trying to test to see that your product meets specification or requirement. So please, one of the questions last week was regarding the specification of requirement. Requirement could be, let's say, performance requirement. And then one of his specification in this case could be based on the latency, let's say 1 millisecond. Let me check to ensure that I'm actually recording this as well. Good, yes. So for the VMV, the static and dynamic VMV, that is static verification and dynamic validation, these are all the activities required. So for static verification, we have 6 activities, and then for the dynamic validation, we have 2 activities, which include the program and also the prototype. So program testing is used to reveal the presence of errors, not their absence. In this case, is if you discover one or more errors, and then you're sure that you have performed a successful test. Types of testing: you have defect testing and validation testing. To discover defects, you conduct defect testing, and then validation testing is intended to show that the software meets the requirements. So please take note of the word intended, which is also one of the questions asked last week as well. So because something has been planned for, it is meant to do something, which is similar to what you have regarding validation, whereby how well you addressed, you address intended address. So the word intended here is very important for this particular definition or explanation about validation testing. So we have testing and debugging. If you try to yeah, so we have the testing and debugging. Usually for testing, you have the defect testing, and then in the terms of debugging, you're trying to be able to locate, and then you fix the errors that you have located. Yeah, so these actually go in line and they go together, and that is why you have a diagram that's connecting the development, testing and debugging. So now we'll come back to those 3 features, which include the VMV planning, also the software inspection, and also the automatic static analysis. So usually for the VMV, what you're trying to do is you want to ensure that you plan from the beginning of your development process. And then if you have a very good planning, you'd get the most out of your testing and also your inspection processes. So please use this diagram for your VMV planning, starting from the verification testing, starting from the requirement specification to the end of the activity required for your planning. And then the structure of the software test plan, you have the testing process, requirement traceability, testing schedule for all the items you have tested. And also you have the testing recording procedures, hardware software requirement, and also those requirements that and those constraints that should be anticipated during your software testing. And here we also have the software inspection. In the software inspections, this actually involves examining the presentation with the aim of discovering anomalies and defects. When you inspect your software, you're trying to discover some anomalies and also some defect as well. Please note, inspection doesn't require executing the system. So when you inspect, you're trying to discover some inconsistencies, some anomalies, or some defect. When if you have to execute a program, and this way, we're looking more of the automated and static analysis, which we're going to talk about in the next 1 or 2 slides. Yeah. So please, inspection can check conformance with the specification, but not conformance with the customer's requirement. What we're saying here is, remember, I can tell you, for example, is we have security requirement, and then confidentiality is one of the specifications of the security requirement. In this case is what I want to check if the confidentiality has been satisfied. So this case, you try to be what in conformance with the specification itself. Then you have your program inspection, which should be a formalized approach to review documents. If possible, you need to be able to see how your inspections are in compliance with the standards we have presented in this unit. And then for inspection procedure, which is usually conducted by your inspection team, this is always performed to inspect what your your product is all about, so that you can be able to discover errors, or maybe trying to look deep into what are those defects you have in your product. So you have the inspection team, and then you have the roles and responsibilities. Let's ensure that you don't have any roles overlap in the roles and responsibilities. And then for inspection checks, you have the data fault, control fault, input, output, interface, and also the execution management. So inspection checks, looking for defect, trying to detect defect, can cut across all these particular features. Remember, you're not correcting any error, you're just trying to detect those errors. And then we'll come to the automated static analysis. In this case, you require some software tools that would support you to perform those checks you have based on, let's say, data, control, input, output, interface, and also static management. It include the exception management as well. So in this case, you have done your inspection, and then you're trying to use those tools, to be able to support you and check those faults in detail. So stages of static analysis, you have from the control flow, data use, interface, information flow, and then also the part analysis. And the use of static analysis, usually, please take note, is if your project supported by a language, ensure that the tool you're using is also supported by the language. It will be a lot more easier for you to detect as many errors as possible, and also to support your project extensively. So in conclusion, verification and validation are not the same. Yes, we said verification, when you're trying to test to see that your product meets the specification, this requirement, in this case, that's verification. And then if you're trying to sell how well you have addressed those needs that are supported by those requirements, in this case, we're looking at what? Validation. Test plan should be drawn up to guide testing process. It's very important when you have a testing plan to guide your testing process. And then starting verification techniques involve examination and analysis of the program for error detection. Remember, please, whenever we're doing our analysis, we're trying to detect errors. We're not trying to cover the errors. Program inspections are very effective in discovering errors. And at the end of the day, is your static analysis tools can discover program anomalies or program inconsistencies, which may be an indication of faults in the code. These are supporting information to guide you in your video as well. And then here we come back to the lecture document. So here, please read this article to give you more information about the Fergan inspection. So search for information describing the Fergan code inspection procedure, similar to what we talked about last week. The Fergan inspection is a process, or is a structured process, or is a structured procedure used in finding defects during your software development. So in this case, if you're finding defect if you're looking for defect or trying to find defect in many documents during your software development process, you use a Fergan code inspection. Write no more than 3 disadvantages of this method. So last week we got some very good advantages and also disadvantages as discussed by the team. It's a very structured procedure, which is also a very good example. And then one of the disadvantages could be because what happens if one of the procedure or one of the processes or one of the sub procedures in the procedure is missing, that may actually affect the other procedures you have in the Fergan code inspection procedure. So please propose a solution for one of the disadvantages you detect in your team, and then see how the automatic tools could be used, to solve the problems. What are the difference between code inspection and also code walkthrough? Please post your answers to the discussion board or forum, and then we can respond to it, and then we can build a discussion from there as well. So this should have been an in-class discussion, but we couldn't go through them in detail because of the time last week. And then we said many of these answers, you can post them to the discussion board, and then we can build up the discussion from there. Select the programming tool which you feel more comfortable with. In this case, look at the programming language supporting your project. Search for a tool that provides static code analysis for that language. In this case, we're using Java. In your project, ensure that the tool also provides static code analysis for Java as well. So write a brief document on the type of analysis that it detects. Please look at the tool very well, read its specification to understand the type of anomalies it detects. Remember, I could have a tool that wants to maybe determine, let's say, the size of, it could be maybe detecting some anomalies maybe from the variables or the integers you have, and then you can have on that tool that maybe doesn't actually perform in that manner. So please read the specification of the tool you're using so that you really understand the type of anomalies that you want to detect as well. Remember, the anomalies that the tool detects is what you need to also detect, because that is the tool you have selected. So we're going to, you would like you to present your findings in the next lecture, and then we can discuss about this in detail as well. So please, in the Appendix I document, take note on the following: static and dynamic VMV, program testing and debugging, VMV planning, inspections, and automatic static analysis. This will help you very well in preparing for the exams. Ensure that you understand all these processes and features and what happens if one or two of them are missing. Look at the diagrams very well. Ensure that you understand what happens after each and every stage, in the diagrams you have. If you have any questions, please feel free to let us know regarding these features. These content are very important for your exam. Take note from one of the questions as well last week is the content will not cut across asking you to write codes or write some programs regarding the tool here, because we know you're using different tools in the project, so we don't expect you to write codes in this regarding this particular content. So here also is discuss this work plan should be carried out amongst performers in the team. That is your project team. So please discuss in detail, present your answer to each other, and then take note of all you have discussed, for your project and also to support your exam as well. So similar to what I just talked about a while ago is discuss anomalies detected by the. So in this case, please, the guideline is look at the tool you're using. Understand the specification of the tool you're using. Based on what specification, you'll be able to understand what kind of anomalies your tools can detect. So please note, some tools are designed to detect anomalies regarding declaration of variables with the size of your integer you have, or maybe to detect if some data is too large, or print issues you have, or array issues you might have, or issues with the compiler, the output from the compiler, or output from of your program itself. So please, these anomalies usually, and also these specifications usually will be related to the tool you are selecting. So please look at the work plan very well. You have gone through the tools, seen the specifications, you've seen what the tool can do for you. So now describe an anomaly, why is it important, and how is it detected by the tool. And then choose one of the anomalies to focus on, and then explain the anomalies and then how the tool detected it. So please follow this work plan to support your anomaly detection by the static analysis tool that you have selected. We would advise, if possible, if you want to use the same tool across all the team members in your team, not a problem at all. That is your decision, because there are so many anomalies that could be detected, right, based on the features we have introduced into the program or how the program really functions. So please use any tool that you feel is very close related to the project you're working on, or is can actually very much help you and assist you in the project you're working on. If you have any questions, please feel free, send me an email. I'm very happy to respond to your email as soon as possible. I'm also very happy to discuss with you further regarding any of the content you might have questions with regarding the week 5 document. We once again apologize for any inconvenience caused regarding uploading the lecture slides last week. And then we hope this recap lecture video will be adequate to give you an overview and also let you know what we discussed about to a great extent in our last week lecture. If you have any questions, send me an email. I'm very happy to discuss with you. I'm also very happy to answer your response to your emails, your questions, and writing as soon as possible. Okay. Feel free to let us know about your project if you require any support or you want us to give you more hints or more insight into guiding you about some of the content in your project. Thank you very much for your time.